Hey everyone, welcome to this episode of the Studio Storage series. Today we're going to talk to Vast Data, and we're going to hear from them how they're taking a different approach to solving the problems that visual effects and animation companies are facing today. Let's talk about it right now on A Cup of Joe. Really appreciate you making time for us today here on A Cup of Joe. This is part of this ongoing limited storage series I'm doing on Studio Storage, where I'd like to step through the vendors and options that are out there that really are making the large and medium-sized studios do what they do. That's how the big comic book movies are made. And, you know, the render needs on storage systems that these require are so unique in the IT environment. They're nothing like the high transaction retail world or anything like that, where thousands of hosts are all trying to reach one single file, sometimes across multiple locations. It's only a handful of folks out there that can really rise to that challenge, and I wanted to bring those folks to the table. One of those folks is Vast here. Vast Data is the company name here. Got Howard Marks, who's a technologist extraordinary and plenipotentiary at Vast Data. I'll let him explain what that means. And I'd like to thank him for coming here to tell us all about Vast and tell us how it helps VFX and animation and what it does differently. So thank you very much, Howard.
Oh, my pleasure, Joe. And extraordinary and plenipotentiary is the term from the days of sailing ships for what we now call an ambassador. Was a minister extraordinary and plenipotentiary. Gotcha. And what extraordinary and plenipotentiary means is that I speak with the voice of the king and can bind the realm in negotiating a treaty. And, you know, basically what it really means is I've been at Vast over 3 years. We've been public exactly 1 day less than I've been here. I joined the day before we came out of stealth. And when you start that early, they let you pick your own title.
There you go. Well, I appreciate you coming out here to explain this. I know you've got a varied background. You've both written, done blogs, you've done reviews, you've dealt with editing. It's nice to see that, you know, not just a technologist, but a technologist communicator. So I appreciate having you here today.
Really, what technologist extraordinary and plenipotentiary means is I get to explain things. And you know, and I've been doing that a long time. I got my first gig in journalism with Computer Shopper in 1982, and spent some time as a journalist and a consultant and an industry analyst, and then came to join Vast because it was a great story and I like telling a good story.
All right. Well, I've heard about Vast now for a couple of years across the industry. You know, word on the street, so to speak, on Vast is growing. I think even amongst my non-M&E compatriots at CW, like they see Vast as sort of an innovator and doing things differently. So it was especially important I brought you into the picture because I think you guys, anyone who can go do it differently, deserves a place to be talked about. That's what we want to hear. A lot of visual effects and animation, a lot of studios do a lot of it the same way. They do what's guaranteed. It's out of a concern for safety. It's out of concern of limiting risk. But as more studios adopt these new solutions, then the risk goes down. They feel more comfortable taking it on, and I think Vast is right in that sweet spot. And so maybe you could explain to me a little bit more, or a little bit about how the technology works and what sets Vast Data different and sets it apart.
What really sets Vast Data apart is that we're an all-flash storage system designed for scale in the 21st century. And so when we set out to design the system, the toolkit, the parts kit we could build from included NVMe SSDs and NVMe over fabrics and storage class memory SSDs like Intel's Optane. And so we had a very high performance, low latency path between the CPUs that provide the compute part of the storage system and the SSDs. And so we built a new architecture that we called DASE, the disaggregated, shared everything architecture to make a scale out storage system with that 21st century parts kit. And so that starts with the fact that we disaggregate the compute portion of the storage system, everything you would think of as running in a controller, physically from the media. The media, there's SCM SSDs, there's QLC flash SSDs. They're in a highly available enclosure with no single point of failure. But all that enclosure does is connect those SSDs to the NVMe fabric. On the other side of the NVMe fabric are the front-end servers. We call them C nodes or compute nodes. They do all the work that you would think of as running in a controller in a storage system. But the difference is because every front-end server has that few microsecond access to all the data that's in all of the SSDs, all the data is stored in those SSDs. And when I say all the data, I don't mean just the data itself, but the metadata and even the metadata like SMB session state is stored in the SCM SSDs in the enclosures where it can be shared by all of the front-end server compute nodes. So we can scale the system by adding more compute nodes to add more performance, or by adding more enclosures to add more capacity. But we do that independently. It's not like a shared nothing system where you have to add another node and that node has to be identical to all of the other nodes. Because our compute nodes just attach to all of the SSDs in the cluster, all of those SSDs and all of those compute nodes don't have to be the same.
Okay.
You can build a heterogeneous cluster across multiple generations of hardware.
And this is where you guys work towards you're removing the tiers. The idea is this longer term vision that you're taking for the data store eventually leads down the idea of kind of getting away from the idea of tiering down through slower storage. That's something that's an important aspect, I think, of.
Well, that's the other difference between us and every other all-flash system. In general, all-flash systems are designed for performance. And when the architect makes a decision between efficiency and performance, they choose performance because the assumption is you'll have a little bit of flash, and since you only have a little, it better be very, very, very fast. Our argument goes just the other way. If you have a lot of flash, if you have hundreds or thousands of SSDs, you by definition have a lot of performance. Performance is no longer a resource in shortage that has to be rationed. It's a resource in abundance that needs to be managed. And so since we have all of that performance from hundreds or thousands of SSDs, we make all of our decisions towards economy. So we do erasure coding, so we protect data against up to 4 SSD failures. But in a moderately sized or large vast system, that only has 3% overhead as opposed to the usual 20 or 30% overhead for data protection. We do data reduction better than anybody else, and we guarantee it. So we have the compression that most people talk about, and we have deduplication that most people talk about, and we've tweaked both of them and they work better. But we also have a third secret sauce we call similarity reduction. So if you think about how deduplication works, if the 2 blocks are identical, you save whatever storage that block takes up. But if there's 1 byte of difference, you have to store that whole block. With our similarity reduction, we find blocks that have large sections in common, and that makes them similar. And we just save the differences between them.
Gotcha.
And that gets us an additional degree of reduction. So when we talk about our VFX customers, they get somewhere between 2 and 3 to 1 reduction on those Houdini and such assets. And they're used to seeing marginal reduction. And we just throw more techniques at it and get it better. And all of that's to bring us to the point where you don't need to have 7 storage systems because each stage in your pipeline has slightly different requirements, and have the MAM move the data from the edit bay storage to the color bay storage to the transcode system storage. But you can have one high performance pool of storage that costs less than that combination of 7 different systems, and avoid all of the data motion.
You don't have separate silos anymore. It can just be one place that everybody is sharing and putting data.
Any vast cluster, whether it's 200 petabytes, 200 terabytes or 50 petabytes, is one namespace. And you can then share folders in that namespace via NFS and SMB and apply quotas to them so that users are limited to that space. But we don't have any of the volume or file system abstractions where you have to manage space between them. It's all one big pool, regardless of, again, what generation of hardware you're running.
Where it's placed on what server is all handled by the software itself, and you don't need wranglers down there putting the data in one location or another.
Exactly. And it's standard NAS protocols, so that you don't need the client agents that have to be kept up to date with the versions of the operating system for parallel or complex or clustered file systems.
One of the things that stood out to me when I saw your guys' first demo was the whole idea of using Optane and then using Flash in conjunction, and the way you guys use the combination of Optane and Flash, and the fact that the Flash you use is not as commonly used, and that seems to give you a bit of an edge. Can you tell us a little bit more about that Flash solution and how it interacts with?
Well, the whole goal of our design is to minimize the cost of Flash so you can use it for more applications, so that you don't have to have multiple tiers for different price bands, but that the total aggregate price would be low, and therefore you could afford to put a lot of data on it. And that started with, we had to buy the cheapest SSDs we could buy. And that meant that we were buying QLC SSDs that don't have the features that people think about for enterprise SSDs. They don't have a DRAM buffer. They don't have power fail protection to protect the DRAM buffer. When you write to them, you write directly to QLC Flash. And QLC Flash has lower endurance than TLC Flash and so on. But how much lower that endurance is very much a factor of how you write the data. If you do small random writes, you get like a 20th the endurance as if you did large sequential writes.
Got you. And by endurance, what you mean is that as you write many files on Flash, it can only take so many new files, so many changes before it starts to effectively, for better term, wear out.
Flash literally wears out.
Yeah. And so that endurance,
any given Flash cell can be erased and rewritten a limited number of times.
Yes.
And that number's smaller for QLC than it is for TLC.
And that's what we mean by endurance in this case. And so you're able to offset that, though, by, like you said, by many different ways, but continue.
Well, part of what we use the SCM, which can be Optane or can be Kioxia FL6 SSDs also.
Okay.
But part of what that layer does is act as a write buffer. So when a user writes to the system, that write goes to that very high endurance, very high performance SSD, where we can coalesce gigabytes of data before we write it to the QLC SSDs in the way that maximizes the endurance those QLC SSDs deliver.
Very large blocks, right?
The spec sheet for the SSDs we use has one endurance in drive writes per day if you write 4K random, and another endurance if you write 128K sequential. We write 1 megabyte sequential. And when we erase 1 gigabyte, again, because it minimizes the amount of wear. We even do things like when we write, so the vast element store, our file system, is a write in free space, logs influenced, but not strictly log structured file system. So when you write, we build these huge write stripes in the SCM, migrate that to the QLC instead of overwriting in place. We write stripes that are segregated by the anticipated life expectancy of the data. So if you write to a .tmp file or a temporary folder, that gets written to a stripe of short-lived data. But other folders and other files go to stripes of long-lived data. So when it's time to garbage collect, the stripes that had what we expected to be short-lived data have very little valid data left because it actually was short-lived. And so when we garbage collect, we have to move much less data and therefore cause less wear on the flash. The whole system, the economies start with, we use the cheapest flash, and then we have to do what the cheapest flash requires to deliver enterprise endurance. And when we talk about enterprise endurance, the other big difference between VAST and everybody else is how you buy it. We don't sell hardware. We engineer hardware. We arrange for our customers to buy it from our contract manufacturer at cost. And then from VAST, you buy a Gemini subscription, which is the support for hardware and software and the license to run the software. So the user experience after you've actually been installed is as if you bought appliances. You call us, we come fix. Doesn't matter, we didn't make money on the hardware. But we'll write that Gemini agreement for up to 10 years from the date of the install of that hardware at the same rate. We don't raise the rates after 5 years to get you to buy more hardware because we don't make money when you buy hardware. We make money when you expand your capacity because the licenses are based on capacity. We want you to have more data. That's all we care about.
The number I use in visual effects and animation for read-write ratio is generally a 10 to 1 or 90% read, 10% write. It's a broad generalization, but it holds up usually. It seems like in the model you've created, it's particularly a good fit for that model. That high end, the idea is the reads don't really affect the endurance the same way the writes do.
Theoretically, millions and millions of reads might, but it's a theoretical.
Exactly, like it's effectively a non-measurable, non-concern. And so and again, in visual effects, you'll have thousands and thousands of one artist will create an update to Thanos's ear culture. I just always like to use Thanos as an example. Everyone's seen the movie. Everyone might one artist might update the ear look of the ear or the texture, but then thousands of hosts and often dozens of artists real time, and then their jobs in thousands of frames are all accessing that new changed file. And that again is a write it down in some place fast acting because everyone's going to use it for a while, and make it as available to as many clients as possible. This is an area, would you say that you fit pretty well that model?
Yeah, our system is designed to be what the people in the HPC world call embarrassingly parallel, so that you can have thousands of hosts accessing a single file at the same time. And the nature of Flash in our system means that the performance asymmetry is that we deliver a lot more read performance than we do write performance for any given environment. And so, that starts the enclosure building block, delivers 40 gigabytes per second of read performance and 5 gigabytes per second of write performance.
Gotcha.
And so it aligns to these very random read patterns in things like rendering, and in a lot of AI applications like facial recognition training, where every time it runs a training pass, it has to look at every photo.
Yeah, that's one thing that we align closely at my company with the HPC group, because so much of what they're working on is what we're working on. And the way, and maybe people who watch me often might get tired of this analogy, but it's sort of like visual effects often takes these race cars, buys them, and then drives them around the parking lot really fast. And the folks in AI and machine learning are literally taking them out to the racetrack and the Autobahn and putting them to the full test of what you can actually achieve in this world with, the GPU, CPU combinations and all of that kind of thing going on. So admittedly, right on the heels of that is VFX and animation pushing limits. So, but don't get me wrong here, but those groups are generally pushing the limits farther on. And now those trickle down of those those technologies and those advances work their way straight in to the latest and greatest things that all the big visual effects animation companies are adopting. There's a direct connection between those, and that's why we have a direct connection internally between our teams, because we simply sell the same gear, the same thing, university, the same servers that are processing university machine learning data out in Quebec are the same, literally the same builds that we have in our data center, also rendering frames for studios. It's the same exact machine.
For us, it's the same storage system at Ingenuity Studios and at Los Alamos National Labs.
See, there we go. It's been a long time since we've seen that come together. Not since the early days of ILM, when their SGI server room was on par. Like I've heard the national security apparatus kind of kept an eye on that little machine room. We're back to getting in parity again with Big Brother. Hey.
Well, people keep coming up with new ideas for technology. I left the movie business in 1982. And so when I did digital special effects for movies, they were very different than what people do today. But the technology just keeps moving on. People just keep getting new ideas. Some of the volumetric stuff is just, well, that takes a whole lot of math, doesn't it? But you get really nice results.
It's true. But yeah, the needs, again, something people are going to say commonly in the visual effects animation world, whatever resource you provide them, the gas will fill the container, and they will not use, they will not do more quantity with it. They'll do more quality with it. They will now make their renders bigger, wider, and now Thanos looks cooler. The Transformers look awesome. All these things that we see out there are because they're constantly being handed the newest machines, and they're not just running more of the same. They're doing a lot more than what they could do before, and that's the growth. It creates a lot of growth in the industry and a lot of pressures, because that stuff gets expensive when artists just triple and quadruple their footprints.
Well, that's part of what we're here to address is, as you do that, we're going to go from 2K to 4K to 8K, and the performance requirements increase. You start hitting where hard drives just can't deliver that.
We started seeing like traditional hard drives back in the day just fall right over with going to 2K, really, right? And then 4K came along, and what people always need to keep in mind, if they don't understand the math of that, it is 4 times as much resource consumption for each level. So to go from 2K to 4K is actually 4 times the resource consumption, whether it's 4 times the processing, 4 times the storage, it's 4 times the screen space. And that you times 4 times 4 a few times, it gets really big really fast.
And even if you can do some of those things with hard drives, the techniques you have to use, it's like, well, if I used 1,000 2-terabyte hard drives, I could get that performance. But 1,000 2-terabyte hard drives cost more than the equivalent flash.
No, and they have the same failure rate. So if you have you got a whole lot more down drives too that are rebuilding, all these types of things. So people got to, that's something to keep in mind with the platters. More platters is great to get you more performance, but it's more things to go wrong, more things to power up, more things to rack up. And cost effectiveness goes down. Yeah, there's a lot of curves that intersect and got to play with. Is there anything else that you feel sets you apart, specifically for animation VFX rendering, that you want to touch on that we haven't touched on already?
The big things are the degree of reliability that, we have 100% availability goal for everything we do. And that means that even things like, vendors talk about, well, you can do non-disruptive upgrades as long as you don't have SMB users, because SMB is stateful and it's hard. So with us, you can do rolling upgrades. Your users won't notice those upgrades. The fact that we store the session information in the enclosure means that when the server you're connected to goes away and that IP address gets transferred to another server, that server can access that state from the session and pick right up. And so, it's a standard NAS system. So it's protocols, and it's no special work on the clients. It's all about keeping it simple.
I wanted to present to as I go through the series, sort of the same set of studios as just as an example. And not everyone fits all the models, but the idea here is I wanted to present an example of three studios. The three studios are such that it'd be like a 50 to 100 person studio, a couple of projects, maybe 100 render servers, maybe 80 to 150 terabytes. What we would generally call in the enterprise industry a smaller studio. There's that tier. Then, of course, there's the medium tier, 250 to 400, maybe 500 people, 2 to 4 projects. That's where you start getting into the 250 to 750 terabyte range. These studios often don't quite hit a petabyte if you don't count the tape. and that they maybe may have 1,000 render servers more densely with like 50,000 cores. And then there's the large studios, the 500 to 1,000 people, artists, that is, studios, 5+ projects, the big 5 or 10, right? 3,000 render servers, 200,000 cores plus on their farm, usually over a petabyte of storage across the board. I wanted to present these three tiers and also not present them just as these discrete tiers, but the reality is people often move through those tiers. A medium studio today is tomorrow's large studio. So we in the storage business are often trying to talk to our clients about, well, what do you need, in the next 2 to 3 years? So we're positioning you with the right setup so that as you grow, you don't have to move everything to a new storage system. It's the last thing you want to do in the middle of a growth spurt is move to a new storage system when you can just grow them. And so what I would ask you,
whether there's a growth spurt or not, a forklift upgrade is never fun.
good point. As we look to that model, where would you say VAST falls within that model, and what do you consider sort of a very loose description of a solution that you would imagine kind of getting rolled out for a studio of this size, knowing that every studio is entirely different and a unique beast?
As our name implies, our systems are rather vast, and today, if you were a studio and you said, I need new storage, I need it today, we come in, our building block is 600 terabytes of usable space. Now, we do partial licensing on that with the Gemini subscription, so you can buy a 100 or 200 terabyte license. So if you really know you're growing that fast, that might be the appropriate way in. But if you are, for the next 3 years, going to be under about 200 terabytes, we're probably not the right solution.
Okay.
The bigger you get, the more attractive we become, because we're the only storage system that allows you to do data reduction over many petabytes of data. That, the problem with data deduplication is conventional systems have to hold the hash table in memory so that when new data comes in, they go, have I seen that before? Because memory is the only thing they have that's fast enough. We have that SCM layer to store it in, so it grows with the capacity of the system. And therefore, we can have one deduplication realm over tens of petabytes of data. So it gets, things get much more attractive at the high end. The basic way you build a system is you go, I need 1 or 2 enclosures based on capacity. I need a pair of 100 gigabit Ethernet switches to support the NVMe fabric. And then the compute servers come in an appliance that's got 4 servers in 2U. And so the starting point would be 1 enclosure, 1 4-server appliance, and the switches.
Okay. And I think, some examples too, you talk about how you can grow by either growing the computer, you can grow by growing the storage. I think when people, maybe give people context on that, some examples would be through the pandemic. Through the pandemic, a lot of the large studios, they accumulated shows that all of a sudden were on hold or couldn't be released. This was needing more storage, but they were increasing their workforce a little bit to pick up some new work, but they weren't doubling their workforce. But all of a sudden they might have double the storage needs. This would be an example where they would grow that storage footprint, but wouldn't necessarily need to grow the compute nodes very much.
During the pandemic, we had a sports league who all of a sudden had their cable channel that they needed to fill, but there weren't live games. And so they added another enclosure to their system and started migrating old game film from their tape library so that they could build clip shows and fill the cable TV channel.
Gotcha.
And
That's another
they,
great example where it's more of a storage problem than a computer problem. I think the flip side of that would be, we've seen now in the last year, a lot of animation studios have grown considerably. I've seen a lot of studios double or more their artist footprint. This is an area where they both need to do a compute and a capacity sort of calculation,
well,
because they're going to need to
one
increase
of
both.
those studios not only expanded capacity and it expanded the compute, so that got the performance with it. But they take advantage of another feature that we have where you can take the compute servers and make pools for performance isolation.
Mm-hmm.
And they discovered that, for some uses, having a dedicated pool for this resource library made their renders run faster. And they have a pool that provides services to the artists, so the artists get high performance.
Mm-hmm.
And they have a pool that provides services to the render farm. And they run scripts so that at night when the artists start going home, they'd start shifting performance from the artist pool to the render farm pool, so the renders can have all the performance that they need while the artists aren't using it.
Yeah, it's fantastic. At studios, a lot of times you will script day and night configurations, often to take over machines on the floor as render machines. But here you're actually using it to change the network.
The quality of service, essentially.
Exactly. And great examples of that are during the day. And effects, I've said this and I'll say it in the face of any effects artist, right? A single effects artist can pretty much take down any studio if they set their job right. And so often putting the effects onto its own robust, often the most robust configuration, but segregated from the end users, means that your average roto person doesn't have a hang up on their Wacom tablet every time this person submits a bunch of these frames, which is this sort of ecosystem problems you see in the studios.
And those problems have historically been solved by giving each of them their own storage system. And that means you need to move data from one to the other as you move through the pipeline. We can provide that performance isolation by giving you dedicated pools of compute without having to have separate pools of data, so that as soon as one stage of the pipeline is complete, the next stage can start. You'd have to wait and now we have to move the data around.
Mm-hmm, mm-hmm. Well, the workflow you described there, it sounds a bit familiar, and I know that type of approach is one of the more sophisticated approaches that people should look to adopt. Anytime you can script daytime and nighttime activities in your infrastructure in a visual effects studio, you're gonna. When I say daytime and nighttime, by the way, that means generally starts off with 8 to 10 hours in the day, but during crunch time, those times change and it ends up being only 8 hours at night to where everybody's actually home or not working. So, but scripting those day and nights and having the ability to move the timer as the shows progress is just a real great infrastructure orchestration you want to undertake. That's beyond just your storage in general. Like I said, render farms and anything you can do to really turn up the volume and put all the nitroglycerin into the render farm at night and then turn it back to the artists in a segregated, healthy manner in the day. You're getting ahead of the curve. So that's great to hear. Okay, well, is there anything on your future more? You discussed it a little bit, but is there things you're working on that you can say that you can say to expect from VAST in the coming months and years? A direction you're heading? Anything you can say? I know that's
we're heading towards world domination.
There you go.
And so there are all sorts of things you should expect there. Early next year, we'll have a new enclosure that is our current enclosure is 2U, holds 675 terabytes of QLC flash. New enclosures 1U holds half as much, 338 terabytes. So that makes us more attractive in that middle. We're continuously expanding and upgrading things like protocol support. So while we do SMB 2.1 and SMB 3 today, in the next few months, we'll be adding support for SMB 3 multi-channel, so you can get the high performance for those Windows and Mac artist stations.
Okay.
The rest of it, unfortunately, I can't really talk about.
That's okay. I'll expect that answer from most everyone. That's the way it is when you're on this side of the NDA. There's something I should have asked earlier for the folks who are trying to save out to S3 storage and other object cloud storage targets.
Well, we are an S3 target. So VAST systems are multi-protocol file and object. So anytime that you write data with one protocol, you can read that. You can write a file with NFS and read that same file via S3. And we have a snapshot to S3 feature that essentially is, self backup.
Gotcha. These are shorter term snapshots, or are these longer term? I guess it's as long as you want to pay for storage. But no, I was more thinking of what I see traditionally for snapshots in studio is a couple of snapshots a day, and then maybe some big roundup at night to allow for people to roll back all the oopses that happen throughout the day. That's probably the biggest snapshot use I see is that right there. Is just a very quick recovery of the oopses.
Right. Well, we have that function, and and users can do self-service restore. By accessing the .snapshots folder that's in each mount point. But the snap to cloud is more a backup.
A DR solution overall, basically more of a DR solution kind of situation.
I avoid DR because it's not a rapid recovery.
Gotcha.
But it is we discovered somebody screwed this up 3 weeks ago. As opposed to we discovered somebody screwed this up in the last 20 minutes. Understood.
No, understood. That's often, oops, we got to pull it back from tape. So, and as much as that may sound easy, because tape only, no, when you need to pull something back from tape, there's opportunity costs all over the place, limited drives that are now not backing up because they have to do a restore, and somebody has to walk down there and shuck a tape, pull it out of there and stick it in. And oh my gosh, what you'd think is just should take a few minutes to copy it off the tape is like 3 days later. So that's great to hear. Great. So if anybody has more interest in this, you can reach out to Howard. You can also reach out to me. I'm happy to put you in touch with folks. And I got to ask this: will you be any presence this year at SIGGRAPH? Are you guys going to be up there hanging around? I'm not expecting a booth or anything, but anybody up there going to be hanging around?
We'll be sending some spies.
Good.
There's always interesting stuff going on there.
Okay, and I will do the plug. Keep your eyes out for the week before SIGGRAPH. There will be a virtual Birds of a Feather happening under the SIGGRAPH Birds of a Feather, and I'll be leading one on storage. I'll make sure to send you the date and time, Howard. I'm hoping that not only do all the studios show up and talk about their storage needs and woes, but it's nice when actually there's folks from the storage places themselves to answer direct questions or say, actually,
as long as we stay in the back and answer direct questions.
Of course. Well, it's a bit of a bloodbath for the vendors to walk in the middle of 50 angry sysadmins from the studio all in one spot who drank a lot the night before. Well, and this is virtual too, so it's a lot safe. Nobody can only virtual daggers. But yeah, I'll definitely invite that. I'll be speaking specifically about all of them, but I will definitely want to make sure that people understand in that forum, what VAST is bringing that's different. And I'm hoping some of your I know at least some of your customers will be there, and they will likely speak to their experiences with you guys, and I believe it will be positive. Mostly,
I like how they do that more than they let me do that.
Yeah, well, the Birds of a Feather are a special, place. It's sort of our annual inner sanctum conversation. It's not recorded, and it allows all the storage sysadmins, and we do the same thing with the render farming one, allows them to just have a moment to speak honestly and openly, and it's a very it's a very pure place where people keep it in the family, what's spoken about, and it allows people to sort of say, how are you getting through this? And they'll say, this is how we do it. And they'll go, wow, that's great. We're going to try that next week. And it's really a wonderful place. And SIGGRAPH is a unique experience in that relative to other conferences where maybe vendors are going kind of at it and there's a competitive sense. At SIGGRAPH, there's no competitive sense between any of the studios. And it's such a unique experience. I didn't know it was unique until I left the industry, and I found now that I gravitate towards it like it's my holy pilgrimage every year to SIGGRAPH to purify myself of a year of sales. Well, Howard, I know this is the last time we're going to be talking. I appreciate you coming on, and probably maybe another year or so we'll have another, what's VAST doing now, which will be even cooler, I'm sure.
Oh yeah, well, a year from now there'll be lots of cool stuff.
Thanks a lot, Howard.
You're welcome. Thanks for having me.